Okay, I'm telling to you that multi-collinearity exists whenever independent variables are interconnected, right? They are not independent to each other. So that is the problem actually. So how to resolve this one? So correlated independent variables make it difficult to make inferences about the individual regression coefficient slopes and their individual effects. So, however, correlated independent variables do not affect a multiple regression region's ability to predict dependent variable. Prediction don't have any kind of problem, but actually, what is the problem? The individual coefficients values may be overlapped, right? Sometimes they have become insignificant. So that need to be handled beforehand. So if we use this variance inflation factor, which help us to identify that is there any kind of this multi-collinearity exist or not, right? So that is the value if it lies between minus 0.7 and 0.7 minus and plus. The general rule is of the correlation between two independent variables between this and this, they are likely not a problem using both of the independent variable, right? But if value is higher, so what you can do, actually, you go to observe the correlation first, right? Between two variables, whatever two independent variables you have, right? If its value is likely falling within this range, then you may assume that both are correlated, right? Both are not independent to each other. In that case, you will apply this variance inflation factor. And once you are going to apply this variance inflation factor, you will get this value. And if a variance inflation factor value is greater than, then it is unsatisfactory, right? Or it is showing that problem, it shows the problem of multicollinearity, which need to be handled. It is basically going to discuss in detail whenever you are going to study 300 course econometrics. So I'm not going to put more time on this. I'm just giving you the hint or idea about it. Okay, what kind of problem exists, and there are some solutions to resolve them. But these are the problems which are actually affecting the results of your estimates, right? Therefore, problems first need to be identified, and then you will go to get the solutions. There are different assumptions we have, and all four problems lies with reference to that assumption. One is the multicollinearity, just like independent variables should not be interconnected. Autocorrelation, that I will show it through this equation because it is making you more sense. This shows the multicollinearity situation, right? Whatever situation this is multicollinearity. So multicollinearity, I will use this word multi, right? So this shows the multicollinearity. If array term is going to be connected with previous array terms, and specifically in terms of time, right? These are calculated over time, right? Then it is called autocorrelation. This is the problem of autocorrelation, right? So you need to resolve this autocorrelation. Heteroscedasticity, we observe that if these variances are not going to be independent to each other, and they are going to not lying in a same range, they are going to vary. The deviation is not going to be stable. Deviation is going to vary, increase, sometime more variance, sometime less variance. So that is going to be shown the problem heteroscedasticity. So these are the three major problems which need to be solved. Another problem is the model specification, and that is related to the whatever variables you have picked for the model. Let's suppose if you are calculating the demand equation, and you are picking the variables just like the number of chairs and the price of tables, and just like the price of number of vehicles on the road, and the number of markets in the city, or just like that, most of the irrelevant variable, then your model may have some kind of limitation, right? That will show specification problem. So that need to be observed. So these are the basically major problems which need to be resolved. Any question from your side? This shows the multi-coordinated problem, how it comes, because usually it is going to make most of the variable insignificant. Once you are going to resolve it, then your variable becomes significant,
Sir,
right?
excuse me.
Did you please?
Sir, excuse me.
Did you please?
Sir, आज quiz किस वक्त decide हुआ है?
I think I will release it at 4 o'clock.
4 o'clock. Okay, sir.
This is to the autocorrelation, and autocorrelation shows that your residual plots and fitted values should not have any kind of correlation, right? Just like it shows that kind of problem exists. So you need to solve it. So sometimes you can even use some kind of dummy variables or some other strategy you can use. Qualitative variables may be used. You know the difference between quantitative variables and qualitative variables? You can also use qualitative variables after assigning some mass or value or weight to the variables and make it in form of numbers, and then you can use it in regression analysis, right? This example is given related to qualitative variables, just like the garage is available or not available. So 0 for not available and 1 for available in a particular home. So these are the estimation with that variable and without that variable. Model significance is evaluated, and then regression is going to be observed and results are going to be tested. Another method is stepwise regression. Actually, this strategy is already given whenever you are applying this. Specifically, if you are going to apply SPSS, it gives you the option that you may use stepwise regression. I just briefly explain you what is stepwise regression. I just show you that this model is run this stepwise regression, and then interaction example interaction variable. So interaction term is used. So this is the whole thing. So I'm just going to move to show you both of the thing, interaction as well as this is that stepwise regression, right? These two things quickly, just taking 2 minutes and 3 minutes. I'm just going to show you by using this quick. One, if you are going to run a model and you are going to include your model, just like you run this model, then next you are going to include this variable and run the model, and next another variable. So that is called stepwise regression. Actually, stepwise regression pick both options. Either pick one by one more variables if more than one independent variable exists. Let's suppose 5 independent variables. So first variable run, then first 2, first 3, first 4, first 5, then 1 and 2, 1 and 4, 1 and 3, 1 and 5, 2 and 3, 2 and 4, 2 and 5. In this way, lot of models are being run through by the software and give you the best, more out of all these models, which is giving more accurate information, more better information that is going to be reported. So that is a stepwise regression. Second way of this stepwise, it is eliminating one by one variables. Right? So both strategies there, either starting from the minimum model to making it larger, or starting from the larger model and minimizing it. So both kind of things there. That is called stepwise regression. You only need to run that stepwise regression if you know that out of a bundle of variables, you have to pick the right variables. So you will pick one by one or few variables, or you put all the variables and apply stepwise regression. Automatically, it will run the regression and give you the best result. So in that result, if you have variable x1, x5, x7, this means only these variables are relevant to y. Right? In this way, you can do that stepwise regression. This is the first thing. Second is, just like in this model, you are going to add another variable, which is x1, x2. This is the interaction term. Multiplied variable means you are using the same variable, whatever are mentioned here in our case, and but just like you are multiplying it and this including this interaction term. And this interaction term actually shows that if both of the variables going to interact, whether they are significant or not, right? Just giving you the hint about this through this example, just like we have this regression, we have run heating cost and mean temperature. So let's suppose we can
सर
generate.
क्लास का टाइम खत्म हो गया है
Yes,
सर नेक्स्ट क्लास का टाइम हो चला है
okay. Just like only 1 minute, so you can just like apply this furnace age and the mean temperature. Is there any an interaction between two? And then you can run the regression and you can find out the result, whether the significant result is there or not. We may discuss in the last class, in the next class. So you can do it by yourself. You can apply both strategies, stepwise regression or both, but stepwise regression option is not here in Excel. So it can be done on SPSS. So it is not required from you, but interaction time you can apply. Clear? Now I'm going to take your attendance quickly, so then you are free to leave. जी, Zaid Ahmed,
Present, sir.
Aiza,
Present.
Mohammed Bilal,
Present.
Javeria,
Present, sir.
Ibhar David, Mohammed Daud,
प्रेजेंट सर
Selina,
Present, sir.
Gondal, Jan Gondal,
Present, sir.
Mohammed Kashan,
Present, sir.
Karamat, Zartab Karamat, Zartab, Haris, Mohammed Ajkhan, Rijan Isar,
Present, sir.
Shoaib, Khwaja Mohammed Shoaib,
Present, sir.
Shazib Khan,
Present, sir.
Nida.
Present, sir.
Okay. Now this is the whole. In the last class.
Excuse
I
me,
just
sir.
went- जी, please.
Sir, मेरी present mark कर दें sir.
Your good name.
मोहम्मद हाशिर खान.
Mohammed Ajkhan.
जी sir.
Okay. In the last class, I just want to make sure that you try to apply this multiple linear regression and go through these slides. If you have any query, any discussion, we will continue that in the last class, right? Because I'm not going to teach anything new in that class. Clear? On Friday.
Okay, sir.
Okay, sir.
Okay, thank you so much, everybody. Allah Hafiz.
Allah Hafiz.